Guys, so here we go with our first flipped lesson. This is lesson 1 for bonding the basics. And what I'd like for you to get from this next, I think it was approximately 15 minutes by the time you're done. I want you to be able to answer why do atoms bond at all and be able to recall the definitions for ionic bonds, polar covalent bonds, and non-polar covalent bonds. We will have some sort of quiz when you get back on the day that this is due. So just be prepared, make sure you understand those concepts, and you'll be good to go. Thanks. So as we move into this unit, I want you to understand at the foundation that bonding happens because of the energy. We're going to get to that in just a second, but we definitely need a definition of bonding to get started. So if you look at section 4.1 right here, where we're starting, all we need is love. Atoms rarely exist in nature alone. They are held together by different types of chemical bonds, which are the mutual attraction. It's a little bit hard for me to write with this pen, but I will do the best I can. Mutual attraction between the nuclei and the valence electrons. Bonding happens in the valence electrons. Okay. Now, why do atoms bond at all? And that is the energy connection. Okay. Nature favors arrangements where the potential energy is lower. Where potential energy is lower. And I'm just going to do a down sign since I'm out of room. In nature, most atoms have higher potential energy alone as independent particles than they do when combined with other atoms, even atoms of the same kind. When atoms combine, the potential energy decreases and stability increases. So the potential energy decreases and stability increases. Stability increases. Now remember, I've tried to encourage you all to use abbreviations and pictures and shorthand as you're taking notes in any way that you can. This is how I take notes and how I try to be able to get as much information down as I can. So you feel free to write them all out if you need to. But again, I would encourage you to start using things like arrows and abbreviations in your note-taking. It will help you out a lot in college. So again, bonding, its outcome is to have the least energy possible, which sounds a lot like us if you think about it. How many of us like to be lazy sometimes and prefer to do things in the easiest way that we can, the most efficient way? Bonding, chemicals in bonding are the same way. So they just want to be lazy. They want to be the lowest potential energy, and that makes them stable. When atoms bond, if you'll look right here, we're down here now. When atoms bond, their valence or outer shell electrons are usually shared or taken. That's going to be your key to the two main types of bonding in order to achieve a more stable, and again, that's the outcome that we're looking for, electron arrangement. And remember, as a general rule, main group elements, those are your first two columns, groups 1 and 2, and then you skip the transition metals and come back over for 13 through 18. Those main group elements are seeking 8 valence electrons to become stable, except for hydrogen and helium, which only need 2 because they can only have 2. If you take a look at the periodic table, they can't have more than 2 electrons. Remember, the name for this 8 valence electrons is the octet rule. You can go on and write that down just to help you remember that octet rule. Bonding in the main group elements. Again, the main group elements are those that are in groups 1, 2, 13 through 18. So in other words, not the transition metals. Not your transition metals. Okay, the two main types of bonding that occur in the main group elements are ionic and covalent. Now the transition metals most likely will be involved in a third one that we talked about in our lab last week, which is metallic. That's going to be the most common there. So ionic bonding has many atoms, atom A, atom B, and you'll notice the electrons are transferred from atom A to atom B. Someone's losing electrons and going to become a cation, because remember, if you lose electrons, you become more positive. Someone's going to lose electrons. When this one, cation, loses, then the anion's going to gain the electrons and become negative. And because opposites attract, positive and negative will be attracted to each other and will bond. Covalent is different. It takes an electron pair and shares them between two atoms. So they share. They do not become charged. That was our sugar last week. Okay, and we talked about that. If you recall, the sugar, when we did melting points, melted so fast because its bonds were weak. So covalent is generally weaker. Ionic is generally stronger. And we will go into that in more detail later on. So ionic bonding, we've already learned that the main group metals tend to lose electrons and main group nonmetals tend to gain electrons. And if you remember on the periodic table, if we're going like this, we're seeking to be like the noble gases and have 8 valence electrons. Okay, so that's why the metals, which are this part of the periodic table, tend to want to lose electrons, because especially when we're talking about main group and just the first two, they have 1 valence and 2 valence electrons. And since they just have 1 or 2 hanging around in that outer shell, it is very easy for them to go on and get rid of the extra 1 or 2, just knock them out. And when they do, they revert back to looking just like the noble gas right in front of them. On the other hand, when you're over here like chlorine at number 17 in the 17th group with 7 valence, well, it just needs 1 more electron to equal 8 valence electrons. So it will tend to gain ones as you get over here, and the ones over here, as we learned in our periodic table unit, are generally nonmetals. Okay, so that's where that whole statement that metals tend to lose and nonmetals tend to gain. Okay, that's another good trend for you to remember as you learn how to use the periodic table. An ionic bond is a bond in which atoms give up electrons to other atoms, and the resulting ions are held together from the electrical attraction of the new ions. I said that earlier, but here's a good spot for us to have an actual definition to study and work with. So, atoms give up electrons, and I'm going to shorten this a little. The resulting ions are held together by electrical attraction. And again, opposites attract. Opposites attract is what that is supposed to signify there. Now we have learned about electronegativity, and that is the ability of an atom to draw electrons to itself in a bonding situation. Okay, you can actually look up the electronegativity of any atom and mathematically determine whether that's going to be ionic or covalent, most likely. We will do that further along in these notes, but bonds between atoms with an electronegativity difference of 1.7 or greater. That's a number you're going to need to memorize. 1.7 or greater are generally ionic. Okay, so if they're lower than 1.7, they're generally covalent. The greater the electronegativity difference, the more ionic the bond. Okay, a covalent bond is a bond that forms from atoms sharing electrons. So let me equals atoms sharing. They seem much friendlier than the ionic bonds where someone is taking electrons. There are two types of covalent bonds, and I bet these words will sound familiar to you. Okay, if the electrons are equally shared. Equally shared. No one is pulling any harder on the electrons than the other. This type of covalent bond is known as a nonpolar covalent bond. And if you think of polarity, you usually think of a positive side and a negative side. So if no electrons are pulling more stronger, you don't have that tension in a positive and a negative end established. Therefore, it is nonpolar. It is not pulling harder one way or the other. It's very equal. And again, that's where the equal comes from. So the resulting electrical charge of the bonded atoms is balanced. It is balanced. These tend to form when atoms have similar electronegativity values, so similar or identical. Similar or identical. They might be the same atom. No more than 0.3 electronegativity difference. Okay, this happens a lot. There are a lot of atoms that like to bond to themselves, and it's called a diatomic molecule. Okay, number 2, we've got another situation in which the electrons are not equally shared. If they are not equally shared, this type of covalent bond is known as a polar covalent bond. The resulting electrical charge is uneven. This tends to form when atoms have differing electronegativity values of 0.13 to 1.7. So if you look at your illustration here, you've got your nonpolar covalent bond and your polar, and I think the picture pretty much says it all. This is a hydrogen, and it's going to be an H2 since there are 2 of them. You'll notice that the electron clouds are equally shared. Okay, I was going to take that drawing out because when I looked at it, I discovered it looks like 2 boobs sitting there, but I thought you might think it's funny, and if you have to do this work outside of class, you might as well have a laugh. So there's our hydrogen boobs. They are nonpolar because they are equal. There's no one nuclei that is grabbing or pulling the electrons any stronger than the other ones. But if you look over here, we've got a hydrogen and a chlorine. Okay, that's actually hydrochloric acid. You're going to notice that the chlorine is more negative. It actually has a very high electronegativity, so it has a lot of power to pull that one electron that hydrogen has closer to itself, and then it leaves the hydrogen nucleus somewhat exposed. So this little sign here just means a little bit of a positive charge and a little bit of a negative charge.